So yesterday we had a discussion on the concept of services, and we understand the concept of service and what type of services we have. So we tried to implement a cluster IP, node port, load balancer type of services. So today we have to take a look on external name type of service practically and the concept of headless service is headless. So this external name, yesterday we just discussed the concept. This external name service is just like a C name record. In any service we discussed uh, will uh, will have an A record in the core DNS of the Kubernetes cluster. But whenever you will create a service, so that service will create an IP to access it from the other pods. So the IP in the cluster, in the Kubernetes cluster is ephemeral. Either it's associated with the pod or either it's associated with the service. Whenever the pod will restart or will recreate by any reason or the service is deleted or recreated, the IP can be changed. So in the cluster, everything we must have to configure by name to make the communication from one pod to another pod, from one pod to service. So everything should be by name. For that reason, in Kubernetes cluster, the core DNS is running, and this is my master node. Of all, I need to check my this kube config environment variable is mandatory. So these two core DNS components are running that are responsible to resolve the name to IP. So whenever we are creating the service, that service will have an IP, and so whenever we are creating a service, it's the responsibility of kubeproxy to provide the IP to the service and make some IP table rules to create the virtual IP from the range of service seeder and make the communication to the CNI we have deployed in the cluster, that is a Calico or whatever CNI we are using. So if your kube proxy is not running, your service cannot create an IP. So it's running as a daemon. We discussed this. So whenever you will create a service, the API server will inform the core DNS that this new service is created with this IP. This is the name. So the core DNS will make an A record entry in the DNS so that all the pods can reach to that service by name. And simply, if you from within the pod you access by name of the service, that will work. And actually, its fully qualified domain name will be something like this. Just if I'm just typing here. So, I mean, for example, you create a service. For example, service BE app dot the name of your namespace name dot svc dot for example your namespace is dev, it will be dev dot svc and then the cluster domain name. By default, cluster domain name is cluster.local or whatever cluster domain name you use. So you can access that service with this fully qualified domain name from any pod within the cluster. So this is the syntax of a record added in DNS. Okay. Okay, so today we have to implement the external name. External name will not make an A record. It will create a C name record, canonical name. Uh, External name concept is just, I mean, external name service is not mostly used in our practical life. Mostly we are using, for example, you want to, what is the concept of CNAME? For example, you have some server that is running on-prem or on cloud or wherever, and you have somewhere a Kubernetes cluster on-prem on cloud. So in the cluster there are some pods. So now these pods want to make the communication to these external servers. So definitely these external servers are reachable to these pods by mm, by some public IP or some private IP, whatever IPs you have used. So each server will have some will have some a DNS name. For example, you can say db.example.com. This is for example, this is database server and it's the DNS name. This is your API server domain.com. Just I'm typing for the example. Okay, and similarly, this is your another server like web.example.com. So when this pod will communicate with these servers, you can directly define in this pod configuration these names. But if you don't want to define these names, sometime you would like to communicate by using the service. So you will create a service, and in that service, you just have to define what is external name, and now the pod will communicate to this service, and this service will make the communication to whatever server you have defined. So let me create a simple service. So yesterday we used the kubectl expose command. So we did this command, we create the service. This command will take the input of any pod, of any deployment or replica set to use with as a selector to make the communication to create the service and to make the communication of the pods. But there is another command to kubectl create service. With this way, you can also create a service. Uh, if I type here help, I can see I can create a cluster IP type service, external name, load balancer, node port. Okay. For example, let me create a service like external name. So external name and then the name of the service. For example, I can say DB server, uh, DB server cloud. For example, a cloud database server is running somewhere that is reachable either by some private network or public network to the cluster. then then we have to define this external name, and then we have to uh, define the external database name. For example, in this diagram, what I use, db.example.com. So here I will use some practical, real example, for example, just like google.com. I'm using this because this is publicly reachable from my cluster. So this will provide me some page, some answer when I will do a curl to this google.com, just for example. And I want to create this in which namespace? So tab namespace. Okay, kubectl get svc hyphen and tab namespace. So here, this service DB server cloud external name is created, and you can see this its cluster IP is not created. You will it is basically it is directly creating the CNAME record in your DNS. So what CNAME record is, whatever you will whenever you will access db.server.cloud dot dev dot svc dot cluster dot local, it will route all the traffic to google.com. Okay, so let me show you the same command with hyphen hyphen try run client hyphen o ym. So you will have an idea. For example, I can say it's svc external name Google. So this service manifest is created, the name and the label is just like the name. There, this is the namespace, and here external name is google.com, and type is external name, not node port, not cluster IP, not load balancer. It's external name. Okay, so this service is created in dev namespace. So let me create some, for example, BE app services. Let me check if we have any pod. I think we ran some pod yesterday. So for example, this is a pod running by some deployment. We used this deployment yesterday. Now I will use kubectl execute this pod hyphen bash hyphen n. Jumping inside pod, I believe ping command is not there. apt update. Just copy the GP server cloud. So now if I do a ping from within the cluster to DB server cloud, you can see it is pointing me to google.com. It is a canonical name. If I ping to google.com, okay, the same IP. So actually, I can also ping this service by this fully qualified domain name dot in the dev namespace dot svc dot cluster dot local. So now whatever running in this pod want to access this whatever the DBs or service, this can access to this service that is hosted outside the cluster by using this name. But you can also use this one, but maybe there could be some specific requirement that you don't want to use the external domain name. In that case, you will create this service. Okay, so this was the concept of external service. Now we have to look, this is the manifest example given. Now we have to look into headless service. Actually, headless service concept is, first of all, we need to, this is our cluster. We set up some pods to run some services. We deployed a service in front of these pods. The service can make the endpoint to these pods. And whatever services so far we created in sense of load balancer or node pod or the load balancer node port and cluster IP. In these three services, we got a cluster IP, an IP that will be responsible to receive the traffic and to route the forward the port to backend to the pods. But in case of this headless service, the cluster IP, when we are using a headless service, the cluster IP will not be available. And any pod that is running inside the cluster, any other pod, by some directly pod deployment or by some replica set, or whatever the way you use to deploy the pod, will communicate to this service, but by the name of the service, but that service name will resolve directly the IP of the pod. That service name, this service name, headless service, does not contain any IP. So now the question is, if I create a headless service that does not contain any cluster IP. Now, for example, this cluster, this service name I created, just like svc dot svc headless. Okay, so its fully qualified domain name will be something like svc headless. For example, I'm creating in dev namespace dev dot svc dot cluster dot. This will be the fully qualified domain name of this service. Okay, so concept so far we understand. Whenever we will ping or do curl or whatever the service way we are using to communicate with this service, this pod will use this fully qualified domain name to reach this service. Now the question is, what IP will be resolved when we will do a ping to this service? Because the cluster IP is not available. So in this in headless service case, the IP of the pod will resolve whatever the endpoint is associated with this service. First time when I will ping, I will get the first pod IP. Second time, I will get the second pod IP. Third time, I will get the third pod IP. Or how many pods we have, I will get in sequence all the pods IP step by step. This will be the way of communication. Now the question is why we are resolving these pod name directly. So far, the method we use of the cluster IP is very good. So what is the reason we need the directly pod IP? So for this reason, we first of all have to understand the STS stateful concept of stateful set. So if I uh, open the definition of the stateful set. So far, we discuss about the replica set and deployment and pod and daemon set. Stateful set. Stateful set is workload API object used to manage stateful application. So what are the stateful application normally in our practical life? It's a database service mostly. Okay, so database service uh, need when we are running the database service. So we need to do the replication among the database multiple container because we also discussed this that whenever we are creating a database pod pointing to the same volume when we did this job in Docker. So we create a database container and that database container had a volume. Okay, so that volume contain the data file. So another pod will, another container will have its own volume. Third will have its own volume. So now how those databases will replicate their data with each other? We will configure the replication among these containers or pods. Okay, so to make the communication in the case of Docker, we can use the name of the container to make the communication from one container to another container. That will work fine. But in Kubernetes cluster, how your pod will make the communication with each other? Because so far, whatever we understand, everything by DNS name is resolvable by the service name and to the service cluster IP. So far we have not discussed anything like any method that will help us to resolve the pod by host name. So now when, for example, these are three database servers. So this database server want to replicate data to this pod want to replicate data to this pod and this to this pod. So how this pod will know the name or IP of this pod? So that's why the headless service will provide the pod level name to IP resolution. Whenever pod will delete and will recreate, it will have the new IP, but in the DNS, the name to IP resolution will be retained. Name will be same. So in this case, the communication among these pods will make very easy. So whenever this pod will use this pod name, so this pod name will be reachable by this service. Okay. So with this way, the replication will be available. If we use these deployments, these three pod like a deployment, so it will create a random pod names. Just like when we are deploying when we have deployed the pod in uh, in the form of deployment. So you can see the names are random. We also deployed, I think, daemon set. I think in the monitoring namespace. You can see a daemon set in Cube system namespace. So you can see this is a daemon set. Its name is randomly assigned. So we don't want these type of names. We need some names meaningful. Okay. So for that reason, what I will do, I need to create some pods whose names are meaningful. So the benefit of using stateful set, you can see stable, unique network identifies, stable persistent storage, deployment and scaling. So there will be some definition. Manage the deployment of the scaling of the set of the pod and provide guarantee about the ordering and uniqueness of these pods. I mean the name of the pod, whenever it does, that pod will be created, it will have the same name next time. If the name is different, then how the pods will communicate with each other. So let me deploy a very simple stateful set. So they are using this copy this one, the stateful set example. Or I think I can use kubectl create. I cannot create by command. This is a stateful set I'm creating. Just copy the template. I don't need the additional things, just like it's using app Nginx. Okay. A label is Nginx, for example, the Nginx is running. Normally the database will run, but just we are for the sake of clearance of concept, I can say it's a DB. And service name is yeah, this is a new thing in the stateful set. We must have to define the service name that will be associated with this stateful set, that will be responsible to directly resolve the name to IP of the pod. So I create. So far I have not created any service. So for a headless service, so name of the headless service we have to provide here. I will provide some name like DB access SVC or simple DB SVC. Okay, minimum readiness replicas. This will create the 3 replicas. Okay, minimum ready second. This is not imperative by default. Just value 0. And this is the label. We can use the same like DB. Name of the stateful set is also DB. Container image I will use Nginx. Later we will use the database too. But so far I am just using Nginx. Because Nginx I have already available. If I provide the database of MySQL, I need to provide the environment variables too. The root password, all those things. So far, I just want to make a very simple. I don't want to define any port. This is not important. The port is not imperative to define. And the volume portion, I don't know. Okay, so this is my simplest stateful set that will create 3 pods with the name DB. So let's see what pod name it will create, how unique the pod names it will be. And the service that will be associated with these pods on top of these pods should be named like dbsvc. Okay, and one more thing, I should create in some namespace service name. The namespace section, I think. In the case of deployment, what I used, just want to see the indentation with the metadata. Under the metadata namespace we defined. Here, the namespace I want to use a dev. Okay, so kubectl get STS hyphen n, or I can just write the complete stateful set too. In the dev namespace, you can see the DB stateful set is deployed. 2 out of 3, 3 out of 3 pods are up and running. And if I query the pods in this dev namespace, so these 3 pods are running under the stateful set, and the uniqueness you can see, their names are 0, 1, 2. This is the sequence number. So every time this pod will be recreated, will get its name like db0, not like some random sequence number. So for example, I'm going to delete this pod db1 from this dev namespace. You can see it's trying to recreate the pod 5 seconds ago, again with the same name. So every time the name is same. So the first benefit, we understand our communication among these pods by name will be same. Okay, now we have to create a headless service on top of these pods. So to create the headless service, kubectl create service. I can also use, I think, expose, and expose way will also work. Let me check both method. For example, I want to expose the stateful set name db in the namespace dev, and having port, for example, external traffic will come on port 80, and target port is also 80, because inside our pod I know Nginx is running. And what else we have to define? Type cluster IP. If I'm not defining that type, it will automatically select the cluster IP. So I'm just creating a service cluster of type cluster IP, and later on I will modify it, hyphen try run. No, you cannot expose a stateful set. There is no way. And even if you look, kubectl create service. If you create the kubectl create service, create service hyphen help, with this way we can create a cluster IP service. Okay, I will just create a very simple cluster IP service because I cannot directly expose the stateful set. I can expose the replica set, deployment, daemon set, but I cannot expose the stateful set. So I will create a very simple service and then I will modify it according to headless service. So I'm creating a service cluster IP. What else I need? The syntax, create service, and then, okay, create service cluster IP, and the name of the service I will say a DB SVC. Just to a dev namespace. Our service name DBSVC. The name service name should be same. So I will choose DBSVC. And then what port forwarding this service will do. I know the target port is 80 inside my container and external port. Okay, I will use also 80. And then try run to client. No YML. Okay. So you can see this manifest is created and I will save this manifest for DB SVC STS stateful set .yml. Database service for stateful set YML. Okay. Database service STS YML file is created. Here, the type is cluster IP. We don't need this cluster IP. We have to make a modification. We have to avoid this service to create a cluster IP. So what I need to do, if I look into this documentation, maybe the service, yeah, there is a manifest. Yes, this is the manifest given for the service. Yes, here we have to define the cluster IP to none. So I explicitly mentioned I don't need any cluster IP. Otherwise, I can write here any IP that is from the range of the service seeder. So when I will define here non, it will not create a cluster IP with this service. So I think everything is good. In which namespace we have to create, we have not defined. Because in the command, I have not used the namespace. That's why it was not reflected. DBSVC stateful set. kubectl get SVC. The dev namespace. So in the dev namespace, I have a service, and the unique thing you can see, the cluster IP is not associated. And the same thing happened with the external name, because this is just a name to name resolution. But here, cluster IP is not there. and external is not there, obviously, but the port definition is defined here. You can send to request on port 80 by using this name. Okay. Okay, now let us try to test DBSVC reachability from some pod. kubectl get pod -ndev namespace. I have multiple pod. I will use again the same pod because I install the ping in this one. DBSVC. I will ping DBSVC. No, I mean we have to ping the by the name of the pod. For example, this is DB1, DB0, DB.s. I think I did a mistake. DBSVC, cluster IP is none, and kubectl. I did a mistake while creating this stateful set. kubectl get STS DB. Yes. The problem is the selector. Yesterday we understand the concept of selector, if you remember. So the selector in the service, I believe, is different. And the service I created here, what selector I defined, I have not noticed. Selector is app DB with this stateful set. So the selector is wrong. See, there is nothing like this selector, whatever I defined. So whenever I will create the service by the command line, it will create that some name with the same name of the service subselector. But we have to define this with our actual environment selector. kubectl apply -f. So now I redefine this one, and now I will go in the pod. First of all, let me list the pod, and let me list the SVC, and now I will jump into the pod, and from this pod I will ping DBSVC. Yes, so this time you can see that directly pod IP is reflected. I believe you got the idea. So now you can see first time when I ping, first time it tried to connect with first pod directly with the IP, with the DB1. And the fully qualified domain name is also having a child domain name like DB1. Second time it connect with DB2 with its actual IP. Third time when I ping, it connect with the third DB2, DB1, and DB0 will also come because it is randomly trying to, yeah, DB0 this time came. So now when I am using the service name, it is using randomly directly associated pods because this service does not contain any IP. So what happened that when I create this service, so API server update in the DNS, the name of all pods with their IPs, whatever right now they have. If I get the pods, can see that it has 11.11, 145.188, 145.188, 253.69, and the third one 116.1.4. So these are IPs directly updated in the DNS. Okay. Now, in this case, whenever we have to make a communication from any application, for example, this was my application, this application want to make a communication with the database server. So now from within the pod, if I again jump into the pod, I will show you. I can reach the pod directly by their name dot the service name dot the namespace dot svc dot cluster dot local. So to reach directly to this pod, I am able to make a connectivity. Second one will be DB1. This pod direct IP is exposed, and if that pod is deleted, the IP is IP is changed. It will also be updated in the DNS. So why we are making that pod connectivity directly? So this scenario again, I will show you. For example, this pod. Why this pod need to communicate directly? Because when we will create a database cluster, so one of our pod will act as a master and rest of as a slave. The master pod will only be able to read write the database queries, but the slave pod will only be able to read. So we must have to define in our application that this is the master pod if you want to do some read write operation on the database. And these are the pods directly you can use to perform some read-only operations. Okay, so this is the first reason. And the second reason is the creation of cluster among these pods also need to identify these each other. This pod should know this pod, how to reach this pod should also know this pod. And if this is master, it will replicate to these pods. Okay, this will also be like this. In this pod should also know this pod. And this pod should also be able to reach to this pod by name. Okay, and it will like be this pod also know about these two pods. So each pod is able to reach to each other by name. So now we will test this. Right now I jump into this pod and I did the DNS name resolution. And now I will jump into this pod and I will access these pods by name. So what I need, get pods. I have this pod. If CTL execute FNIT. I have to jump into this pod in dev namespace. I know this is an but image is running its Nginx, and also I know the ping is not there. Okay, now I have ping. So what I will ping, db 0. DB0 is my IP, DB1 and DB SVC dot tab namespace dot SVC dot cluster dot local. You can see this pod can communicate with other pod. DB2, and it can reach to itself also by name. So now when you will set up the cluster among these, whatever the database you are using, Postgres or MySQL or MongoDB or Microsoft SQL or Oracle or whatever database you are using inside the container, you can make a replication. So replication need a strong communication over the network. So these name will provide a strong communication. This is a benefit of using headless service. So these pods inside also take the leverage of the service that is deployed on top of these pods to make the communication, because that service made the entry in DNS and that is reachable by all the pods in the cluster. So any pod can reach to these pods directly, and these pods can also communicate with each other by using the name. So for example, if I delete this pod, just quickly, I want to show you. So let me just change the IP of some pod. Maybe sometime it is providing the same IP, sometime it will be new. So last time it was 116.1.4. Yeah. This time is 116.1.3. Okay, let me jump into the pod. Let me ping to TB2. You see how quickly the DNS update the IP. Last time it was pinging to 114. Okay. So actually, whenever you are making a communication with the DNS, there is a time to live. Even whenever I am browsing some websites or my browser or my computer, my window, or Linux, whatever I'm using, it will cache the name to IP resolution for some time. So that time to live is provided by the DNS server. So in this case, the time to live is very low, I mean almost zero. Every time it will ask from the DNS. It will not cache any DNS last time used. So every time it will, the pod will ask to DNS to provide me the IP. So this was the whole story about this service concept. We'd look into detail the concepts of how these pods are. How, if you read this whole document, you will get a lot of other concepts too. But I mean the ideas, but the core concept we did in detail. If you have any question uh, about the service, so we are going to take a 3 minutes break. And after 3 minutes, we will resume. We are resuming now. So we are done with the with this service part. Uh,
सर एक क्वेश्चन है छोटा सा.
जी.
मैं सर, if you provide any guide regarding certification of CK, do you have any guide or do you have any book regarding CK? So can you share that?
So you can go directly to the Linux Foundation, and
Okay,
everything is mentioned there about CK certification.
okay, okay. Do you have any guide, official book?
No, there is no official book. We just need to cover. I don't know. I am using this Kubernetes.io. Everything is
Okay,
mentioned there.
okay,
So whatever topic you will see here in Linux Foundation, they will provide you all the certification content you have to cover. You can
okay,
follow this documentation to that.
okay, okay,
Okay.
okay, okay. I got it.
So
Thank you.
welcome. Okay, now the next topic we are starting is persistent volume. So far, whatever pod we ran does not contain any data persistency. So volume uh, is a way just like we use in Docker to preserve the sub data, whatever you will change in pod. So there are multiple types of volume available. Some volume are ephemeral and some volume are persistent. If I open the ephemeral volume, first of all, I need to give you the idea. I want to see some, maybe they gave some picture. No. So uh, I will explain you here. This is your cluster, and inside your cluster you have pod. Okay. And this pod, whenever end user is accessing this pod by using this service, so end user may be preserving some data. For example, this is a database service, a pod. So the front end application pods are making, or the back end pods are making communication to these database pods to, and writing some data. So data persistency you need. So what you will do, you need some storage to make the that you will mount with your pod to make the persistency. So same thing we did with the pod, with the Docker. So this will write, uh, just copy this. Okay. So this pod will have its own storage, and this pod will have its own storage volume. So why they are not sharing? Because the stateful application cannot share their storage, because this database will make a lock on this storage. We did this exercise in Docker. So now this storage must be out of the cluster. If you lost everything in your cluster, so you should be able to recover your data from some external storage. So each pod of the database will have its own storage, and now these pods will do the data replication, whatever method you are using. Like this, and both storages will be updated. If you lost this whole cluster, you can recover because this storage is outside of your cluster. So in on-prem Kubernetes deployment, we are using NFS-based storage. And for on cloud, there is NFS-based that is normally known as uh, some file system based storage provided by cloud, or there is on cloud you can also provision the block storage, just like the hard drive we are attaching with the virtual instances in cloud. That hard drive is directly associated with that pod, but that hard drive will be out of the cluster. And you can also use the cloud object storage, just like S3 in AWS, to save the data within your pod directly. The pod will point to S3. But in case of databases, mostly we are using block storage. So each pod will have its own block storage to save the data. So now what we need to understand here, how this will work actually. This was the conceptual diagram. But in fact, how Kubernetes cluster will create the volume reachability from to this pod. For example, this is your storage outside of your cluster, and you can say it's an NFS-based storage. So this pod need to access this storage. So how many steps this pod need to follow to reach to this storage? In when we did in the Docker, it was very easy to just use a -v and volume to attach the external directory with the internal directory of the pod. But here we need to create a PVC, persistent volume claim. We need to define inside our pod a persistent volume claim definition. We will create persistent volume claim as a resource. I show you here kubectl, so yep, inside the pod, kubectl API resources. So here you can see the persistent volume claim. This is a resource of Kubernetes cluster that we will create with some definition that how much storage we need and from where we need. So we will define this PVC in our pod manifest. And this PVC will point to some PV. PV is the persistent volume. And PV will actually be pointing to the external storage, or whatever the storage. It can be different type of storages. But persistent volume will actually be responsible to provide the storage from wherever it is coming. So these two, persistent volume and persistent volume claim concept, we need to understand. This is also a cluster resource, you can see this resource is namespace based, but persistent volume is cluster based resource, mean from within any namespace you can create a persistent volume claim that will be associated with persistent volume. So whatever persistent volume claim you will create, it will try to connect with the persistent volume. So to look into the definition, how the persistent volume claim is working, this volume definition I opened. So if you look this documentation, here you will get the idea what type of storages you can attach with your cluster. Here they talk mostly about the cloud-based storages like Azure Disk, AWS Elastic, Elastic Block Storage. Okay, self storage you can attach. Cinder. These are different type of storages. So right now we are just going to build a very basic concept about the storage. The storage are different types. I mean, within the cluster you can also provide and outside the cluster. So far we are just going to make a concept of within the cluster. So if I type here persistent volume claim, persistent volume. If I look by the command line, maybe there is a way to. I think I cannot create a persistent volume by the. No. So I must need the manifest of the persistent volume claim. So here they gave an example. Yes, this is an example of persistent volume claim. But before that, we need to create a persistent volume. So to create an NFS-based persistent volume, there is a concept of storage class. I'm just looking for some manifest. Yeah, this is the example. They are using some volume directly associated with the NFS. Let me just check some example from. Yeah, this is some GitHub repository that is providing us this. Yes. this persistent volume manifest I will use. So here this is the kind is persistent volume. The name is, I can say, the NFS PV, persistent volume. Storage is, I will say, 1 gigabyte I need. Read write many mean multiple pods can connect to this storage. This is also a read write once. I mean only one whenever if one pod associated with this storage, other cannot access this. So and there is also a read only many. I mean all can access this, but in read only mode. So right now I'm just using a read write many, and here I have to provide the NFS server IP. So NFS server IP, for example, I think I have an NFS server. It's IP, I think 101. I will show you. And then the path of the NFS server that is exposed. And mount option, we don't need to define this NFS variant. So let me first of all check I have my NFS server up and running. So I created this uh, I'm creating a directory KS and I'm defining in the my exports file. You can see some documentation how to create an NFS share. And inside I will say this is DB 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 PV DB1 PV first database persistent volume. I think hyphen is not allowed. DB1 PV. Just giving full permission to, I mean, everyone can read this. Because within the cluster, when some user will try to write, whatever the user is, that will be able to write here. Okay, so this export of NFS is done. The IP of the server is 101. Okay, now the pod is actually residing on this worker node. So both worker nodes should have the driver to read the NFS. I will install, I think there is some package, I don't remember exactly, to provide the NFS utils. PT update. I will just query quickly equal to NFS utils package install. It will give me the at least the package name that I have to install on all my NFS kernel server. This is the name of the package. So I will install apt. This package I'm directly installing from the console. I mean, this package will provide the drivers to connect with the NFS server. Because when the pod will try to connect with the NFS from the host machine should have all the required packages. So how can I query from the my worker node directly that is reachable to the NFS? I will use the show mount command. Show mount command is a Linux command that is we can use to test the connectivity with NFS. My NFS IP, you can see it showed me uh, all the exported volumes sent. So I will use this K8SDB1 PV. So this volume I will use to connect with this server. So let me quickly install the dependency on the second server too. Okay, so we deployed both NFS node. Let me run here. Show mount -e. Uh, sorry, 110. So this is also reachable. Okay. So now I know K8SDB1 PV is my NFS path. So here I will define key it as db1 persistent volume. So let me just query for also install here ipt update from the master node. Also I will try, since master node will not be responsible to host the application load, but just for the testing I'm doing this. So this is our special volume mount point, we the export we will use for this PV, just to make sure any to avoid any issue. Okay, so this will be our server, and this is the IP, and we defined in persistent volume. So now I have to apply this, and if I do a query, I can see the persistent volume is created, but this persistent volume is just a definition in the cluster, and this resource is not coming any under any namespace. So that's why I have not provided a namespace. But this is just a definition. So far, this PV does not try to make a communication with the NFS server. The whole communication will happen when we will set up our pod. That pod will connect with PVC. PVC will connect with PV, and at that time, PV will try to hit to that NFS server from whatever node that pod is hosted. So we can have multiple nodes. So far cluster don't know which pod, which node will demand this storage. So far we just give a definition inside the cluster that this is our up and running, and we verified from the command line it's working. So if you do a describe PV PV, so this we have created. I need to do one thing. Uh, I will make some minor change like NFS for database 1. It should be meaningful. This PV is dedicated for the database 1. Okay, this is created, and if I describe this, so you can see read only false mean read write is available, and access mode is RWX, X mean many. All the nodes can reach this. So if I change this to uh, mean this access mode definition is also defined here. Here the definition is. We can set up these three definition in our uh, PVC manifest. That read only once mean only one pod can connect this, and only read only property. And read only many, all pod, multiple pod can connect with this persistent volume, but only read only. All pod can access it with read write many. And read write once pod mean only one pod can connect to this volume and with the read write privileges. So when you are creating this persistent volume for the database, in that case, this will not work. This will work initially, but any other pod will try to access this storage, because you allowed to many multiple pod can write. So all other pod that will try to use this database data file will fail, because the lock will be available, will only be written by the first pod use this. So for the database purpose, we will use read write once. This should be the practice. So far we are just making a concept. So that's why we just gave to read write many. Now the first part is done. This part is done. PV we created. Now we have to create the persistent volume claim. So for the persistent volume claim, uh, there will be, or I can go to the same, here they gave the PVC. Yeah, this is the example. The web server want to access the PV and NFS and NFS server, and this is the persistent volume. So here I will use this PVC YML. PVC, I will write something like DB1. So now persistent volume claim, and the name is NFS DB1 PVC. Any meaningful name you can give. And read write many mean this PVC is attachable to multiple pods. For example, you will set up one more pod, and you can also redirect the other pods to this PV. So then both pod will get the same storage from the same persistent volume claim. Read write many, I'm using storage class concept. We have to discuss this, and it will request some 500 megabyte, for example. So it will try to search when I will apply this. The volume name is NFS. I think this is not mandatory. So this will try to search and one more thing I need to give the namespace. Otherwise it will go under the default namespace. So I will create a persistent volume claim under the dev namespace. And okay, so now I am demanding a 500 megabyte. Okay, so 500 megabyte will search when I will apply this. Right now, if you see kubectl get PV, and now I apply kubectl, it is created. I will query PVC under the dev namespace. So you can see it is created and bounded. And if I now query the PV, you can see the difference. Last time it was available, but now it's bounded. Bounded to what claim? Whatever claim I created. So this is attached with this PV. So now if I try to create one more this for example, I want to create one more persistent volume claim. Okay, for the second database instance. And I just do a minor modification. And it also need 500 MB, or I can say it need 1G. Okay. So what I will do, I will just apply kubectl apply -f. Let's see what happened. PV and PVC under the dev namespace. So you can see the second one is in pending state because this PV is trying to bound with some persistent volume claim. So far we don't have any persistent volume. Only one was available that was associated with this, the first one. So I need to create one more PV uh, and its storage size should be equals to 1 GB or more than 1 GB. If I create a persistent volume that is of 100 MB, that will not comply the requirement of this persistent volume claim. If I do a kubectl describe PVC, this one from the dev namespace, it's a size is not mentioned here. Yeah, it is just giving me the message that events that it is trying to connect with the persistent volume, but no persistent volume available to claim the storage. Okay, and just to show you YML format, we are demanding 1 GB. So what I will do, I just need to create one more storage directory. PV1 I created, I will create PV2 and I will set the permission. And in my configuration file, I define a new one and export fs -r. Quickly, I can do a show mount. So the second one is also created. So what I will do, I need to copy all PV TP1 all P TP2 and I am demanding, for example, 2 GB. It will be a 2 GB. I did some mistake. Ah, it should be TB2 because already the same name is available. So now I have two persistent volume. It is in state available and persistent volume claim in dev namespace. And you can see it is bounded now. It was waiting and it was available for some seconds and some retry happened from this PVC and it bounded to this persistent volume claim. So now both are occupied. So when you will create a new PVC, new claim, so it need another persistent volume. So now our this PV is created and PV is bounded with the PVC is created and PVC is bounded with PV. So we create two PVC, two PVC and two persistent volume, and both are pointing to different. Both are pointing to different storage. Okay. So now if I will set up another pod that will be connected with this one. It will have its own storage. Okay. So we have done this part. Now I will set up a pod, a simple pod, not the deployment one, to see how this will use this volume. So it's manifest. If I go here, there will be some examples or yeah, web service. This is a deployment and service example is also given there. So NFS web service, this is a deployment and I think I can use yes, this is the example where I have to define my volume and volume mount. And persistent volume is not defined here. Yes, here they define the volume. So let me just create a simple pod. kubectl. I think I already have, for example, this app1 YML. I will just modify this manifest to make the communication with the persistent volume claim. So here, first of all, I need to define this volume section, and that will be indentation is parallel to container under the specs. I will check the indentation again. The claim name is indented, and the claim name I have to provide whatever actual claim I created. For example, this one I want to connect. Okay, so this volume definition I defined here, and its name is my PVC. This name can be any name, and but this should be the actual PVC name. Now the second part is we also have to define this volume section under the container definition. This volume is parallel to specs, and this is parallel to container. This indentation is wrong. It should be like this. Okay, so now this name, I can have multiple volume in this container, but so far I use only one. Okay, so what directory I want to attach with this? So far I will use the, for example, Nginx I will use, and okay, and I know USR share Nginx. HTML is the web root of my Nginx, and that will go to this my PVC, and that is pointing to this one. So far I am just using Nginx. Later on we will also use the database. So I just use this database persistent volume claim that will point inside the container to this path. Okay. So how this will work, I need to apply this, and this volume is actually, this path will be taken from this one. This name is same. If I do this name different, like web root, then I also have to write here web root. And I believe this is also going dev namespace. Okay. And let me apply this. The error is, I think the pod is already there. CTL dev namespace. The pod is not there, but there is some problem in the indentation. Sometimes when you are copy pasting from sometimes when you are copy pasted, it will make some indentation problem. Pod is this? Okay, everything is good. Bad request if a pod variant v1 cannot be handled at a pod strict field specs volume mounts unknown field volumes. volume mounts and volume. Okay. This indentation is wrong. Under the specs, it should be indented, and under the container, it should be indented. This is this is a problem. The dev namespace, this pod is created, and now if I kubectl execute -it, this pod -n dev, inside this pod, I know this is Nginx, and under the USR share Nginx HTML. Okay, there is nothing. And if I go to my NFS server, and if I go under the K8 S and DB1 PVI associated, there is nothing. If I create a directory here, test, I will be able to see the same data inside the pod. You see? So actually, whatever you will save, it will go directly under the NFS. So far, we just make a test, but practically we will deploy some database that will write the data, and then we will delete that pod, and we will see the data persistency of the database. So far, what I can do, I can test one thing. Just quickly to show you one example. I'm connecting with my NFS server. Inside my NFS server, I will deploy some website template. So I'm just copying this template. I downloaded this template. I unzip this template and tr. I need to remove this and mv. We did everything like this in our Docker. But so what I did, I just download the website whole content, and this is reached here automatically. You can see. Now if I quickly do kubectl expose pod app1 in dev namespace with port 80 pointing to 80 and type node port okay, it will create a node port that will expose this pod. So kubectl get svc and the dev namespace, you can see this app1 node port created. And if I go outside this cluster and I try to reach from any node, this pod, this website is hosted inside my Kubernetes cluster as a persistent volume. Okay. So now if I delete this pod, okay, kubectl delete pod, dev namespace, this is not reachable now. This is down. What I will do, I will reapply the same manifest and it will connect with the same persistent volume that will make our pod again up and running with the same data. So it will give me error. So now what I need to do, I need to just apply the same manifest that contain all the definition of persistent volume, and my persistent volume claim and everything is intact. PV, comma, PVC. You can also get the resources like this. So persistent volume is available and persistent volume claim is available. So this is same pod again created. And when I will do a refresh, that is again up. Because data was persistent in this pod by using PVC. So when I will do kubectl describe pod app1 in dev namespace, so you can see the volumes mounted definition. So this path inside the pod is pointing to webroot, and webroot is pointing to persistent volume claim whose name is this, and read only is false. So with this way, you can track down how the data persistency is working. So for today, we have done a basic end-to-end connectivity with this concept PV and PVC. So we can do this with the deployment and whatever you application you use. So you need the concept to clear the concept of PVC and PV to make the data persistency. So we are done for today.
Thank you, Asim. Thank you so much.
Okay.
Thank you, Asim. Thank you so much.